my function generator and oscilloscope project. I'll first start demoing the function generator. I have this LCD screen which displays the peak-to-peak and frequency values, and these buttons are used to adjust those values. One is for a bigger step and one is for a smaller step, and then the leftmost button is, while it's being held down, will count in reverse. So this is how it is when it's booted up, 3.3 volts and 1 kHz, and it's connected to the lab oscilloscope. And as you can see, it's a 1 kHz and 3.3 volts right now. If I increment the frequency using a small step, it goes up to 2 kHz, and this also changes to 2 kHz. And same for the peak-to-peak voltage. I'll count down. So if I go down to like 2.5 volts, this also goes down to about 2.5 volts. And then for the frequency, or the oscilloscope, I have it connected to, there's 2 channels on our lab function generator, and I've connected them to my channel pins here, the yellow and the blue wires here, and then the greens for ground. So for channel 1, the blue channel, currently it's set at 1 kHz and 3 volt peak to peak, and then there's a 1.5 volt offset just so that it doesn't send negative voltages into the microcontroller. So if I turn that function on, I have a Python script running on my laptop that gets sent over the USB using UART to my laptop to display this. So there's the waveform. It's at 3 volts peak to peak, starting at 0 because of the DC offset. And then if I change this to say 2 kHz, then you can see the wave frequency increases on there as well. Or if I change the amplitude, if I go down to 2 volts, it also changes the wave down to 2 volts. And then the same for the other channel. If I switch channels, this one's at 1 hertz and 2 volts. I turn that on, and this wave also shows that. And then same goes for this. If I adjust this to say 1 volt there, and at 2 volt or 2 hertz there, it also changes that wave. And so that is the complete demo of my project. There's the oscilloscope portion and the function generator portion.